Hi guys, Miss Baynard here. So this is your similarity and slope pair deck assignment. So we're just gonna go over some of the questions. So this is slide number 5. It's your first task. So they want us to give a sequence of transformations that shows that triangle ABC is similar to triangle A prime, B prime, C prime. So in order for us to prove similarity, we need to describe a sequence of a sequence of transformations. So that includes rigid transformations and dilations. That takes one shape to the other. So we're gonna. It doesn't matter which one you go. You want to take the smaller shape to the larger shape, or the larger shape to the smaller shape. It doesn't matter. So I'm gonna take the green triangle and move it to the blue triangle. So I am going to translate. So, and there's many ways to do this. Remember. So I'm going to translate triangle A prime, B prime, C prime, and I'm going to translate it 2 units up, 2 units up, and let's see. Actually, no, it should be 3 units up. It should be 3 units up, not two. Okay, 3 units up, and 1, 2, 3, 4 units right. All right, so that would put it right about here. So it would look like this. That would be B prime. This would be A prime, and C prime. Let's see, it's 1, 2, 3. 1, 2, be right about here. So here's where we would be after that translation. So now we would need to dilate. So in order for us to dilate, we need to figure out the scale factor. So I'm going to change colors here. So we look at segment AB and A prime B prime, their corresponding sides. So A prime B prime has a length of 2, and AB has a length of 1, 2, 3, 4. So we know our scale factor is going to be 2 because 2 times 2 gives us 4. So 2 is our scale factor. And then we're going to, after we translate, we can dilate triangle A prime, B prime, C prime by 2. And then we have to pick our center of dilation. And the center of dilation is always going to be the corresponding points that are on top of each other. So we only have one pair of that's B and B prime. Point B or B prime, it doesn't matter. But that's how you would complete the first task. All right, let's go to the next one. All right, so they want us to dilate the triangle using a scale factor of 1/2, and the center dilation is the origin. So in order for us to do this, we need to create rays that go from the center of dilation, which is the origin, through each point that we want to dilate. So normally we would use a ruler to do this, but I'm just going to go ahead and freehand as best I can. So we are going to along these rays, along the rays we just created. So 1/2. So normally what you would do is you would take your patty paper and say, well, how long is this? Fold it in half, wherever that halfway mark would be. Let's say that's there. And that's where C prime would be. And then you do the same thing. You take your patty paper, trace the ray between the center of dilation and the point you want to dilate, fold it in half. Halfway would be about there. That's A prime. And do the same for B. And let's just say halfway is there. B prime. And then you would connect your dilated points and say, there we go. That is the triangle dilated by 1/2 using the origin as the center of dilation. All right, let's check out the next one. All right, so 7 is similar. However, the scale factor is going to be 2. Since the scale factor is greater than 1, your shape would be larger instead of smaller. But it will be the same process as we did in the previous slide. Let's go ahead to 8. Let's erase this line. All right. So for 8, are the following triangles similar? Explain your reasoning. So remember, similar shapes have the same angle measures. and the sides would be scaled by a single scale factor, but we don't know anything about the side lanes, so we just need to look at the angle measures. So hopefully you remember that the inside angles of a triangle all add up to have a sum of 180 degrees. Okay, so we know that this symbol here represents a right angle, so that's 90 degrees. So we know we have potentially one pair of corresponding angles with C and F. But if B is 35, what has to be the measure of angle A? So we would have to take 180 minus 90, which is 90, minus 35, and we would get 55 degrees. So that means angle A has to be 55 degrees. And since it's the same measure as angle D, angle A and angle D would be corresponding angles, which makes angle B and angle E corresponding angles. So that's how we prove that those two triangles are similar. All right, let's go to slide 9. They want us to find the length of side B. So for similar shapes, we know that the corresponding sides are proportional. So for this one, we have to set up a proportion. So using corresponding sides, we know that side AB is corresponding to side XY. So it doesn't matter which one is your numerator or denominator. So we have AB is corresponding to side XY. Okay. And then let's change the spin color. We know that AC corresponds to XZ. So we have AC, and that's XZ. All right. So now we just kind of fill in what we know and solve. Let's see. So we know AB is 15, and AC is B. That's what we're solving for. And XY is 10. And we have XZ is 8. So we need to try to figure out what proportion would help us figure out B. So this is kind of a little bit difficult to see at first, but if we can reduce this fraction here, 8/10, we can divide both numbers by 2 because they're even numbers. And we get 5 over 4 is going to be equal to 15 over B. Well, we know that 5 times 3 is 15. So whatever we do to the numerator, we have to do to the denominator. So we're going to scale it by 3. So B has to be 12. So that's the length of side B is 12. All right, next one. Which slope has a line of 2? Remember that slope is going to be our vertical change over our horizontal change. Remember, vertical is up and down, horizontal is left and right. So which line has a slope of 2? So 1, 2, 3, 4. So that's 4 over 2. This is 4 over 4. That has a slope of 1. All right. And C, would it be 2 over 1, 2, 3, 4, which has a slope of 1/2. So A. Line A has a slope of 2. And our last slide. We have to thumbs up all of the ratios that would give us the slope of the line. And remember that slope is vertical over horizontal. All right, so let's see. MN, that's horizontal. So that one would work because that's going to be horizontal over vertical. KL is vertical, so that checks out. And JK is horizontal, so this works. NP is vertical. We said JK is horizontal, so that works. JK is horizontal, so that wouldn't work. NP is vertical, so that's good. NM There we go. That works too. And then we have NM, which is horizontal, so that would not work. Actually, I made a mistake here. So this NP over JK actually would not work because the vertical side and horizontal side have to be in the same triangle. So there we go. That's your slope and similarity pair deck.